Welcome back, guys. This is a quick short video on the trigonometric concepts which are very useful for solving the vectors. So let's say I'm gonna start with a right angle triangle. So first of all, tangent theta, cos theta and sine theta. These trigonometric identities can only be applied to right angle triangles. So tangent theta is equal to opposite upon adjacent. Cosine theta is equal to cosine theta is equal to adjacent upon hypotenuse, and sine theta is equal to opposite upon hypotenuse. You might have studied Sohcahtoa in your previous classes, so it's the same concept of Sohcahtoa. And let's say this angle is theta. So first of all, we need to understand when we are taking any trigonometric ratios, tangent theta, cosine theta or sine theta, if this is the angle theta, all my opposites or adjacents will be with respect to this angle. So opposite to this angle. When we say the opposite side does not mean that it has to be vertical side always. Opposite to this angle will become the opposite side. And then if this is the longest side is hypotenuse side, and this side becomes the adjacent side, adjacent to the angle again. This is the adjacent side, and the longest side is the hypotenuse side. So if I change the angle under scrutiny, if this is the angle under scrutiny, this is the theta angle now, and then this will become opposite side, and this becomes adjacent side, and this becomes hypotenuse side. So we need to make sure which angle is under scrutiny. Depending upon that, we will select our opposite, adjacent and hypotenuse. All right. So let's say we are given a person covers a displacement of 10 meters at an angle of 30 degrees north of east, and the displacement is 10 meters, and angle given to us is at an angle of 30 degrees north of east. So north of east means you will have to start from east and you will move towards the north. That's how you will measure the angle. And if you are given the angle delta D is equal to 10 meters, let's say 30 degree east of north, then how you gonna represent it on the navigation system? Then you will represent it as this angle as 30 degrees, starting from the north moving towards the east. So starting from this end, this vertical end, moving towards the east, this angle becomes the 30 degree now. So make sure you are reading the directions properly. And so this was a bit about the direction. Let's go back to the question. So this was the original question. This was 10 meters. I'm going to erase this so that this does not create any confusion in our work. And this is 10 meters. I wanted to find what is the displacement of person in the x direction, delta dx and delta dy. That's what I wanted to find out. So basically I wanted to find the components of this vector in x direction and y direction. That's what I'm trying to find out. So what's gonna happen is this angle, this is 30 degrees. If I complete the right angle triangle, means I wanted to find this value. So rather than drawing it on the vertical axis, what I'm going to do is I'm going to pick it from here and I'm going to move it. I'm going to try and move it on this end. That's how. And I will erase this thing and erase this and this draw. So this, if you represent it on this side or you represent it here, both sides are the same, because if I complete it from the top also, this becomes a rectangle. In a rectangle, what is the property of a rectangle? Opposite sides are always equal. So this side is equal to this side and this side is equal to this side. So what we've done by replacing this vector from here to here is we've completed a right angle triangle. So this becomes a right angle triangle, and this is 30-degree angle is given to me, and the hypotenuse given to me now is 10 meters. And I wanted to find this component and this component. So I'm gonna, if I wanted to find this horizontal component on the x-axis, what I'm gonna do is I'm gonna apply the cosine formula, because I wanted to find the adjacent side. This angle is 30 degrees, opposite to this becomes opposite, this is an opposite side, and this becomes adjacent. Hypotenuse is already given to us. So I'm gonna use this formula, cosine theta. So cosine theta, cosine theta is equal to adjacent upon hypotenuse, and hypotenuse value is 10 meters. So this is 10, and this adjacent we don't know. Let's say this is x, and cosine of 30 degrees is given to me. And first of all, I have to make sure that my calculator is in the degree modes, and then after that, by checking that, I will file the value. The cosine 30 is 0.866 equal to x upon 10, and then if there is nothing in the denominator, we'll put 1 and then cross multiply. 1 times x is x, and 10 times 0.866 times 10 is equal to 8.66 meters. So we figured out the displacement in the x direction. That is this value is, adjacent side is, this is 8.66 meters. So in x direction, person has covered 8.66 meters. And then I wanted to find the opposite side. For opposite, I wanted to find this value. Notice now, because I know this value 8.66, even if I'm going to apply this formula, I'll be able to solve this question. Either you apply this or this, you both by applying any formula, you will get to the, you'll lead to the same answer. So I'm gonna do it with sine theta. Sine theta equal to opposite upon hypotenuse, and this is 10. Opposite value is, we don't know, I'm gonna call it as y, sine of 30 degrees, and then sine 30 degrees 0.5 times 10 equal to y, which will be 5 meters. So the vertical component came out to be, opposite side came out to be 5 meters. I can do it by applying the tangent theta also. Let's see, tangent theta equal to opposite upon adjacent. So tangent 30 is equal to 0.57 equal to opposite what I wanted to find out. We called it as y, and adjacent is 8.66 times 8.66. That's gonna give me y equal to 4.99, which is approximately equal to 5 meter. So hopefully you were able to understand how we can resolve the components of a 2D vector by applying the trigonometry. Thanks for watching.